welcome to Algebra 1, Lesson 22. So yesterday we talked about the additive property of equality. Today we're going to talk about the multiplicative property of equality and how we use that to solve equations. So we are going to get started by looking at a similar problem to what we looked at yesterday. 2 equals 2. We know that this is a true statement. What if we multiply both sides by 3? So I have 3 times 2 and 3 times 2. Well, I get 6 on this side, I get 6 on this side. I get the same answer, logically. So that means that it's still a true statement. So according to my multiplicative property of equality, if A on one side of an equation equals B on the other side of the equation, I can multiply both sides by the same number, here, C, represented by C, and I'll get the same answer. And then I can multiply it either way. I can multiply it in the back, A times C, or I can multiply it in the front, C times A. Either way, it's going to give me the same answer because we've already learned from the commutative property that it doesn't matter the order that you multiply things in. Okay, as long as we do something to one side, we have to do it to the other, and it comes out an equal answer. So let's use that to solve a problem like this. 4x equals 12. Now again, you see this repeated, 4x equals 12, 4x equals 12, and I'm going to show you why in just a minute. So starting out, 4x equals 12. There are 2 ways we can solve this. So this will be way 1, this will be way 2. You need to know and understand both because some problems you can really better solve one way than the other. It'll be easier. And you'll see what I mean as we go along. So 4x equals 12. I am multiplying 4 times x. So I know from other examples that I want to do the opposite of what I'm doing to x. Since I'm multiplying x times 4, I want to divide by 4 to get rid of it. So 4x divided by 4, and it's easiest to show with that fraction bar. Whatever I do to one side, I have to do to the other. So 12 divided by 4. So that cancels out my 4 on this side. So I'm left with x equals, well, 12 divided by 4 is 3. So I have 4 times 3 equals 12. I'm checking it now by putting 3 in the place of x. 4 times 3 is 12. 12 equals 12. Boom. My problem is correct. So now you're thinking, Miss Ashley, what's the second way to solve this? Okay, glad you asked. So the second way to solve this is that we need to remember something. The number 4 has something called a reciprocal. Remember the reciprocal? That's when you flip it. I don't mean flip it like this. No. That's just flipping it upside down. No, not talking about that. Okay? I mean when you flip it by putting this on the bottom. Because 4 could be written like this, 4 over 1. That's the same thing, because 4 divided by 1 is itself, it's 4. So I'm going to flip it to find the reciprocal. Doesn't equal, excuse me. Its reciprocal would be 1/4. Okay, that's the reciprocal, 1/4, where I've flipped it. I put this on the bottom and then on the top. So that's the opposite. If I multiply something by its reciprocal, what do I get as my answer? 1, right? Because these cancel, because 4 goes into 4 one time, 4 goes into 4 one time, and so I'm left with 1. That's my rule. When I multiply something by its reciprocal, it gives me 1. When I divide something by itself, it gives me 1, so that cancels it out. So that means I can also multiply something by its reciprocal to cancel it out. So I can multiply both sides by the reciprocal of 4 in order to cancel out my 4 and get x by itself. So this cancels out 4. I'm left with x equals 12 times 1/4. 12 over 1, 4 goes into 4 one time, 4 goes into 12 3 times. 3 over 1 is what I would get here, and that becomes 3. X equals 3. So see how I got the same answer? And then I would put x in place, or 3 in place of x, and check my problem. I'm not going to for time's sake. So you can use either the reciprocal method or the division, doing the opposite method. Okay, so now let's look at some examples to help give you confidence with these. There are a lot more examples than just 2, so we're going to be going through a lot of examples, I think about 5 or 6, to help you gain confidence with how you can solve these problems. So So the first one is 5x equals 20. I can do the reciprocal or I can do division. For this one, I'm going to do division. I'm going to divide both sides by 5. That gets rid of the 5. I'm left with x equals 20 divided by 5 is 4. Then I put 4 in place of x. 5 times 4 equals 20. 20 equals 20. My answer is correct. Okay, let's move on to the second example. 2/5 x equals 7. If I divide by 2/5, this is possible. Okay, you can do that. You just have to understand that then you have to flip it in order to do the division. But that's a little bit more complicated, right? So I don't want to do that. I want to do something that's a little bit easier to visualize. So instead, I'm going to choose to multiply by the reciprocal. The reciprocal of 2/5 is 5 over 2. And so I'll multiply 7 by 5 over 2. That's a little bit easier than the division, right? It's a little easier to visualize. So my 5's cancel, my 2's cancel. All I'm left with is x equals, well, we'll put 7 over 1 to multiply. 7 times 5 is 35. 1 times 2 is 2. So it's 35 over 2. It is acceptable now to leave this as an improper fraction. I know it wasn't when we were in elementary together, but now you're in colegio, so you can leave things as improper fractions. You don't need to change this into a mixed number. So 35 over 2 is your answer. We put that in place of x in order to check. So we have 2/5 times 35 over 2 equals 7. Make sure that you put the correct fraction back. Don't put the reciprocal, put the correct fraction that we started with. Be very, very careful when you're checking. Okay, my 2's cancel. 5 becomes 1. 35 divided by 5 is 7. So I have 7 over 1, which equals 7. 7 equals 7. And my problems check. Okay, let's go to our next examples. Okay, let's finish up our examples and our practice. Look over here, I have 2 and 1/4 x equals 3. The easiest way to continue this problem is to go ahead and change your mixed number into an improper fraction. So I know that 4 times 2 is 8, plus 1 is 9, so it becomes 9/4. Okay, that makes it a little easier to work with. So the last one I looked at like this, which was the 2/5 x equals 7. The easiest thing to do is to multiply by the reciprocal. So I'm going to flip this, and it will become 4/9. And I will multiply both sides by 4/9. This cancels out, so I'm left with x. I have 3 over 1 here. 3 goes into 3 goes into 3 one time. 3 goes into 9 3 times. So 4 times 1 is 4. 1 times 3 is 3. So x equals 4/3. I'm going to plug that back in to check it. 9/4 times 4/3 equals 3. My 4's cancel. 3 goes into 3 one time. 3 goes into 9 3 times. So that's 3 over 1, which equals 3. So my problem checks. X over 3 equals 9. Okay, I'm dividing by 3. What's the opposite of dividing by 3? Multiplying by 3. So that's all I have to do in this case. I have x divided by 3, so all I need to do is multiply by 3, which is also the reciprocal of dividing by 3, because this is like 1/3. But just know that you're multiplying by 3, that's all you need to remember. So the 3's cancel, I'm left with x equals 9 times 3 is 27. So I put 27 in place of x. 27 divided by 3 equals 9. 27 divided by 3 is 9, so 9 equals 9. My problem checks. Okay, well, let's keep going. 2 more examples and then your practice. X over 2 1/2 equals 7. Okay, it might be a little hard to read that this is 2 1/2. You can always look at your example 22.5 on page 101 to follow along a little better if you're having trouble seeing on the board. So I'm going to first start by changing my mixed number into an improper fraction. That makes it a lot easier to work with because it becomes 1 unit there. So 2 and 1/2, 2 times 2 is 4, plus 1 is 5. So it becomes x over 5 halves. So what am I going to do? Well, just like here, when I was dividing by 3, the easiest thing to do was to multiply by 3 to cancel it. I'm going to do the same thing. I'm dividing by 5 halves, so I'm going to multiply by 5 halves to cancel it out. Okay? Because this becomes 5 halves over 1. Let me write this down here just so you can see it a little better. This becomes 5 halves over 1 times x over 5 halves. Okay? So these cancel out, and you're just left with x. All right? So I'm left with x right here. X equals, this is 7 over 1. 7 times 5 is 35. 1 times 2 is 2. So once again, I have 35 over 2, similar to our last problem, right? That we had like this. Okay, so I'm going to put 35 over 2 where x was, and I have 5 over 2. Looks complicated, but it's really not. Okay, so I have 35 over 2 divided by 5 over 2. How do I do that, Miss Ashley? Don't forget, this is the same, this right here is your division symbol. So this is the same as 35 over 2 divided by 5 over 2. So just think of it like that. What do you do in this case? We flip-flop the 5 over 2 to make it 2/5, and we multiply. So these cancel. This becomes 1, this becomes 7, and we get 7 as our answer. So 7 equals 7, and my problem checks. That's the fun part about math. You can manipulate numbers in all kinds of ways as long as you follow the rules. Okay, let's check out the next one. Here I have p divided by 3 halves equals 4 1/3. Okay, I'm going to do the same thing that I did over here. I'm going to multiply both sides by 3 halves. Because that cancels out this over here, and I'm just left with p. This becomes an improper fraction. 4 times 3 is 12, plus 1 is 13, so this becomes 13 over 3. My 3's cancel, so I have 13 over 2 equals p. I put that in place of the p. 13 over 2 equals 3 over 2, which should equal 4 1/3. Let me do my work over here. I have 13 over 2 divided by 3 over 2. So that means I'm going to flip-flop and multiply. So it becomes 2/3. I flip-flop 3 halves to be 2 over 3. Cancel out my 2's. I get 13 over 3. 3 goes into 13 4 times with 1 left over. So it's 4/3. 4 1/3 equals 4 1/3. Problems check. We're good to go. Pause now and do your practice. Okay, you should be back now from your practice. Letter A, x equals 5. You should have multiplied both sides by 1/4 to get x equals 5. Letter B, x equals 45 over 4. You should have changed 2 2/8 into an improper fraction, excuse me, of 18 over 8. Multiplied both sides by 18 over 8. That would give you 90 over 8, which reduces to 45 over 4. Letter C, x equals 45. You should have flip-flopped the 3/5 and multiplied both sides by 5/3, giving you 45. Letter D, z equals 10. Change 3 1/5 to an improper fraction of 16 over 5. Multiply both sides by its reciprocal, 5/16. So 32 times 5/16 equals 10. today. So I hope that you have a great day. Finish up your problems, do your very best. Let me know if you have any questions. I'd be happy to help you. Bye.